Hello, my name is David and I'm Developer Relations at Particle Network. And in this workshop, we're going to go over how to build a simple application using BTC Connect over the B2 network. So what we're going to build is an application that allows you to use your regular native Bitcoin wallet to send EVM compatible transactions through the B2 network. So BTC Connect is one of the Particle Network's SDKs and essentially combines Bitcoin Layer 2s with account abstractions allowed by ERC 4337 standard. So basically allows the user to control a smart account on an EVM-compatible Bitcoin Layer 2, in this case B2, simply with a native Bitcoin wallet as its signer. In our case here, I'm going to use Unisat, for instance. So one of the main features that we're gonna display today in this workshop is actually how BTC Connect allows users to interact with EVM applications only using the single entry point of the native Bitcoin wallet. Here I'm gonna show you a quick demo of what's gonna do. We're gonna have an application that is gonna allow you to use a wallet, one of the Bitcoin wallets. In this case, I'm gonna use Unisat to connect to the application. And then we're going to have two simple interfaces here, one to execute an EVM transaction and one to execute a BTC transaction. So essentially, this is just a very simple transfer from one address to another. So let's, before we start coding, let's go over a brief explanation of how BTC Connect works. So basically what it does is that it's allowing you to associate one of the native Bitcoin wallets, like Unisat in this case, to an EVM EOA style of account. So what's happening when you connect to your Unisat wallet, around BTC Connect basically uses the Bitcoin public key to create and generate an EVM EOA. And in turn, it's used to create a smart account, which is going to allow the Bitcoin wallet to be used as a signer. So, this essentially allows you to control both EVM transactions and BTC transactions from the same Bitcoin native wallet, which greatly increases the UX for users. And at this point, we can start talking about the actual project. So I'll briefly go over the repository that you're going to find associated with the workshop here. The README is pretty extensive and it gives a whole bunch of explanations and how to set up the project from either the repository or from a React project from scratch. And so the fastest way to start is just going to be cloning this repository, following the instruction to set it up. So what we're going to build is that an application based on create React app using JavaScript, Tailwind CSS for the styling, BTC Connect from Particle Networks that we already talked about, and Ethers.js version 6. So before you can get started with the actual coding, let's create a project in the Particle Network dashboard because we are going to need a few codes and APIs in there. So from the Particle Network dashboard, we can just create a new project and we can name it how you want, but I'll name it BTC Connect. I already have another one named similar, so I'm just going to keep it BTC Connect, save it. This one is going to spin up a basic project. And for this project, we're going to need the project ID and the client key. And then we are going to create an actual application. In this case, it's going to be a web application. And my web app is also going to be called BTC Connect. And it here actually requests you to put a domain. You don't need to have one. If you already have it, you can place it there. Otherwise, you can just use a placeholder like this. A placeholder is going to do. And this is going to unlock your application with the app ID that we are going to need to actually run the application. And then if we're going to go over a second here for the Particle Network dashboard, you can see how you have all your application detail. You can see the activity from the users. You can edit your branding. You can see user details. And you can also set up your paymaster and add funds if you want to in that case. So now we can start getting over the application itself. All right, so now we can start with the actual coding part. Here I have set up a very basic React project where we're going to only work on the index.js and app.js file. So basically how BTC Connect works is that it wraps your application in a Connect provider object. So the BTC Connect provider object basically allows you to configure your application where you're going to be able to choose the account abstraction options, the networks that you want, and the BTC wallets that you want to include in the connection application. So we're going to first start by importing those options from the Particle Connect, from the BTC Connect kit, where here we are importing Connect Provider, which is the object that we need for the configuration itself. The OKX connector, Unisac connector, and BigEgg connector, which those are the three wallets that we want to allow in our case. And then the B-Square mainnet and B-Square testnet. So our wallet is going to work with all of those. Then we can start basically wrapping the application with the Connect provider. So as you can see, we have the application here, and we can just include the Connect provider around it, just like. Now let's go over the various configurations before we move on. So as you can see, it's importing the project ID, client key, and app ID that we got earlier from the Particle Network dashboard. So make sure you place those in environment variables somewhere in your application so the app can actually access those. And then we have the account abstraction options. In our case, we are using chain IDs. We're importing the chain IDs for the B-Square mainnet and testnet. We're importing the chains from the Particle Network /chains here. And the .id method is going to extract the chains ID that are allowed. So basically, those are the two chains that are going to show in the actual wallet model. Version 2.0, the B-Square testnet is only supported by version 2. So we are using version 2.0. Version 1 will work anyway, I guess, for the mainnet, but the version 2 has a little bit better gas optimization, so might as well use it. And then we can have wallet options. Visible is set up to false right now. These wallet options is just the Particle Network model that shows up in the corner of the page. I want to disable it for now because I want to showcase how we can do all the interaction only by using the main Bitcoin wallet. And then the connector is going to allow us to display the various wallets that we want to allow. In this case, I want to allow all three of them. So I keep all three of them. Otherwise, we could just remove one of them. So once we set up the configuration like this, we can start and move on coding the actual application. As you can see here, the application is actually empty right now. And how we're going to start building it is just importing the classic React hooks and configuration plus the Particle Network configuration from the BTC Connect kit. So we're going to use state and use effect in this application. And from the BTC Connect kit, we're going to import the use ETH provider, use BTC provider, and use connect model. So those hooks are basically how BTC Connect handles the majority of the work, where the use ETH provider is going to allow us to give us to get access to the Ethereum provider. In our case, it's going to be Ethers, and then to the accounts and the chain IDs that we want to use. While use BTC provider is going to give us access to the accounts for BTC and sending the transactions. And then use connect model is going to be the little UI that shows up when you want to connect to the Bitcoin wallet and choose which wallet you want to use. Next, I am going to build a couple of utilities, function, and components. So essentially, this network info component It's just showing the little squares where it's going to show you which networks the wallets are set up on. So there is not too much of a need to go too much over those. As you can see, we're using Tailwind CSS in this application. Feel free to just use your the regular CSS if you want. I enjoy Tailwind. It makes it a little bit more straightforward. And then a second utility function is this truncate address, and it just basically cuts the address down and display it a little bit cleaner on the UI. Then we can start building the application. So we're going to initialize the app here. And the first thing that we're going to do is we're going to set up some of the hooks and some state variables. So let's go over those. From the hooks that we imported from the Connect kit, we are initializing the provider, account, and chain ID from UseIt provider. So those are the parts and the hooks that we're going to use to interact with the EVM part. From use connect model, we import the open connect model and the disconnect functions. So those are what's basically going to allow us to open the model where we choose which wallet to connect and how to log out. And then from BTC provider, we import accounts, send Bitcoin, and get network. The accounts basically is allowing you to extract which account is connected from the wallet. Send Bitcoin is the function to send Bitcoin to another account. And get network is just identifies which network we're on, if it's testnet, mainnet, and so on. Now we have some state variables here that we want to set up using useState. So the first three state variables are what we are going to use to basically display balances and display which network BTC is on. And then the next ones are going to be the displaying the EVM address and the BTC address. Remember, the EVM address is the one that is generated directly from the Bitcoin key when we connect. And these last two are mostly utility ones. Just we have a simple functionality to copy the address and a few error messages displayed. So that's those are handled by them. Next step, we are going to initialize the custom provider. So the custom provider is what is basically allowing us to interact with the EVM part. In our case, we use ethers.js. And remember that this part here using ethers.browser provider is the one for ethers v6. We have other versions available. We can use v5 as well. v6 is the latest one, so we are going with that one. So the custom provider allows us to interact with the EVM part of the network, pull the balances and send the transactions and so on. An extra utility here that I'm adding, it's fetching the B-squared network. So this is really just to show which network the B-squared wallet is set up on, and is going to get into the network info component here. So we are basically fetching the chain ID from the wallet and see where we are on, and we're just displaying it there. So not too critical, this part. But let's start getting into something a little bit more interesting and important. We start to have use effect here to start fetching the balances and the network from the Bitcoin accounts if something changes there. So what we do here is that whenever one of those 4 variables changes, we're going to run this. And first of all, we have a little condition. We are checking if a custom provider is set up, if an account is available, and if we have any accounts.length. So this is basically a way to see if the user is essentially logged in. If the user is not logged in, then we are going to return the function here, and it's basically just going to display the connect button. But if the user is already logged in, it's going to start fetching a few things. So we're going to use the custom provider to start fetching the balance of the EVM account And then we just use the set balance function here to parse it using ethers and just set it there to display in the UI. For Bitcoin here, we're going to fetch the network. So basically, this is when you connect to your wallet, you're going to be able to choose which network you're on, if it's LiveNet, Mainnet, so on. So this one is just going to display there. And then this API here is used to basically fetch the balances of the Bitcoin wallet. BTC Connect SDK right now doesn't have a native function to do that, so we do it from this API here. And I added a little try-catch block here, because if you use it too much, it's going to start giving 429 errors, and it's not going to show anything in the UI. You don't know why. So if you start getting rate limited, then at least you have a message that says that. Then if we get the balance, we parse it and display nicely in the UI. Then the next part that we can do is handling the login. So in this part here, we do something very similar to what we do with the condition in the use effect to fetch the balances of the net and the network. So we basically check if there are accounts. If there are no accounts, it means that the user is not logged in, and so we're going to call the open connect model function, which is going to open the window where you can choose which wallet to connect with. Pretty straightforward, this part here. Then we can go into starting to actually make some interactions. So the first interaction I want to cover is the execute transaction EVM. So this is basically the EVM transaction that we set up. We do something very similar to the login. We just check that we have a custom provider set up. These little conditional checks are just there, so it avoids the application crashing if one of the states is not updated and things like that. So it just keeps things a little bit cleaner. And then we basically take the signer from the custom provider, which is, remember, is ethers.js in our case, and we just build a simple EVM transaction, which is very straightforward, just how you do it in any application. Essentially, we build a transaction. To the destination is going to be this EVM address, which it's taken from the UI that we're going to build in a moment. The value we are sending 0.01. In this case, is going to be BTC, right? Because we're working with BTC, but Ethers parses it like that. And we don't send any data because we are not working with any smart contract. But if you were trying to call some smart contract function, then you will fill that up. And then we can really just use the signer object to send a transaction. We wait for a response, and from the response, then we extract the receipt hash. In this case, we're not doing much with it. We're just displaying an alert here that say, hey, your transaction went through, and here's the hash. That's it. You can add more functionality here if you want. You can add a UI that lets you connect directly through the block explorers and stuff like that. Then we can add the Bitcoin transaction. This one is even simpler. We are basically using the send Bitcoin function that we imported from BTC Connect, and we are taking the BTC address from the UI, and we are setting up to send one Satoshi like this, and then it's just going to display the hash when we return the hash there. The last part here is going to be a simple utility handler again. We have a little function here to copy the address from the UI. So that's simple as that. No need to pay too much attention to this. And then the logic for the actual interactions using BTC Connect is done. So as you can see, pretty straightforward like this. We can, the last part that we can add here is just the UI. Again, the UI is really just regular JSX, so I'm not going to cover this too much. But the things that we want to check is just we have this condition here that if we don't have any account, if the application doesn't read any account, it's going to display the button to connect and call the handle login function. And then if we have accounts, it means that the user is logged in and is going to display the UI for the actual application. Now, we're not going every single part here of the UI, but remember that it's going to be available in the repository. So you can go fetch it from there. It's a little bit more efficient. Now that we have the app, we can see how it actually works. So we connect, and I said we use Unisat. And then we have the two options, send an EVM transaction on a BTC or a BTC transaction. I'm just going to send some BTC, in this case 0.01, what we hard coded there, to one of my wallets. So we're just pasting it here, click execute transaction, and as you can see, we can confirm we are sending 0.01 here. We confirm it, and it's going to pull up my Unisat wallet to sign the transaction. So we sign it, and then the alert is going to show up here. And then we could go check here on the B-Square network Explorer where this transaction is at. And we will be able to do the same thing with BTC. Can add one of my BTC addresses, execute transaction. And now I can sign my transaction here from the same wallet, and done, sent. This one only sends one Satoshi, so it's very small value, but still. And then that's it. You see how we were able to use the same Unisat wallet to interact with EVM, BTC,